the scariest SpongeBob ever.
Okay.
I thought he was going to blow up.
I'm glad he didn't blow up. But I think something just hit my lower intestines. We're looking at page 300, problem 37. Welcome. It was a line from that SpongeBob episode. Come on, seriously, guys? You got to keep up with this. It's on the midterm. So let's see. I've got 2m all to the half power times m to the half. And one of the things I want to point out is be careful. Make sure you try to really emphasize the fact that these fractions are exponents. I have had some people doing like this, and that just looks like m times a half, not raised to the half. So I know it's kind of tough because they're like exponents and tiny and then writing fractions that are tiny. Yeah, you know what I'm saying. So let's see. Step 1, I've got a parentheses here, and I can distribute an exponent over multiplicado. So I'll have 2 to the half, m to the half, m to the half. Let's see, and let's see, 2 to the half.
Why is there 2m to the half?
Because this m is to the half, and that m was already to the half. So m to the half times m to the half, what do I do? Multiplying two things of the same base, you add the exponents. Add them. Right, and 1/2 plus 1/2 is 2/2, or 1. So I could actually just leave my answer as this. If they wanted it in rational form, or I could write that as m times, what does 2 to the half mean? The square root of 2. And I write the m first. I always write radicals after my other stuff, just so that way if I wrote it as the square root of 2m, it's hard to tell if this vinculum was like, you're mine, m. You know, like, so you just want to, like, you know, avoid that vinculum creep potential there. So that's why putting it at the end, it's like, he can't, like, sneak over here and somehow loop around and steal m, you know what I'm saying? So there we go. So this is rat expo form. Seriously, I've got some mouse problems in my house. You got to figure it out. And this is radical form. Rad, right? Because the radical. Radical. So let's see. Problem 41. X to the negative 5 power. So a negative exponent, I will move it downstairs. Actually, that's not quite yellow enough that I'm looking for there. There's a little more yellow. Yellow, right? So, so move it downstairs and make its exponent positive. And I will get x to the positive 5/6 power. Ugh. And who lives upstairs?
1.
1, the loneliest number that I ever knew. And now you actually aren't allowed to have fractional exponents in a denominator. That's the same as having a radical in the denominator. So it might be easier for me to translate this into radical form. What does x to the 5/6 mean? The 6th root of x to the 5th, right? And now the question is, how do I get rid of this radical in the denominator? Because if I multiply by the 6th root of x to the 5th, that would give me the 6th root of x to the 10th, and it wouldn't cancel out. So I want to multiply it by some exponent that will add to be 5 to cancel with 6. And so that's just regular old x to the 1st, or x, right? So let's do that. Let's do that work over here. So 1 times the 6th root of x is the 6th root of x. Over the 6th root of x to the 5th, I'll write this out, times the 6th root of x to the 1st. You add the exponents. And what's this going to be? X. And technically it'd be absolute value of x, but we're ignoring the signs of x for now. We're just pretending they're all not negative. So this is radical form, and I also could have written that as rational exponent form. What would my numerator be as a rational exponent? X to the what? the 1/6 power. So, depending on what is requested in the problem, I may accept either answer, or I might say write it as a radical, and if you write it as rational exponent, I'd be like, a no. To make sure you know the difference. So, rat, right? Rad. And actually, sometimes my lowercase r's for rad, notice that this kind of looks like a square root. Am I right? But I guess, wait, that has an r in it too, so that doesn't help. But rational is just like fractional, right? So there you go. So make sure you know the difference between those two things. I'll guess, keep the crossbar on my teeth. Bam, bam. And done, done, done. 43. This one is essentially our classic landlord problem, properties of exponents. We just have a lot of fractional exponents. That's all. So let me rewrite this. This is just b to the negative 1/2 all over 8b to the 1/3 times b to the negative 1/4. Now, you could make a lot of work for yourself if you don't think ahead on this problem. And you wouldn't be wrong, but you could be like, oh, I want to move this downstairs, I want to move that upstairs. Oh, and then I'd have to add some too, and then, oh, okay, then I have to subtract the little guy from the big guy. And you could end up dealing with like a whole bunch of fractional arithmetic stuff, and that would be a pain because you would have had to find common denominators on multiple occasions. However, I know that at the very end, I'm going to only want 1b represented here. So that means all of these exponents at some point are either going to be added or subtracted, which means I'm going to want them to have a least common denominator. There can only be one per season. Do they ever have just like Ultimate American Idol where they have all of the American Idols come back and compete against each other in a Thunderdome match doing rational equations?
I don't think so.
That'd be so sick.
Okay.
Except for none of my people ever win because they always are runner-ups and it's stupid.
I'm sorry for your loss. So guys, anyways, friends, what is the LCD between 2, 3, and 4? 12. All right. So that means I'm going to have to multiply each of these by
What does LCD stand for?
least common denominator. Good question. Multiply by 6 over 6. Multiply this one by 4 over 4. Multiply this one by 3 over 3. Man, my fraction work is so small. It's small. So let's see. This will be b to the negative 6/12. This will be b to the 4/12 times b to the negative 3/12. All right, so that's just going to make things easier for me. Now looking at these, what b's do you want to combine first? Yeah, let's combine these two bottom ones, right? So in the bottom, the denominator. Oh, I got it. Oh. Oh, sneeze. No?
Same one.
Fake sneeze. I'm sorry, everybody on the internet. I'm sorry.
When I say that, I don't want to fake a sneeze and it doesn't happen. I just pretend to sneeze anyway because I don't want to.
Yeah, because the worst face to have is, yeah, like doing one of these, especially if someone like doesn't see that you're going to sneeze and you're like, they don't know that you're going to sneeze and they just see you from across the room and you're like,
You don't know what I do when I sneeze?
and then they're just like, what happened? Like, I don't understand. So that's unusual if that happens, obviously. That's the worst. It's almost as bad as like when you're across the room from someone and someone waves to you, and then you wave back, and then you realize they were waving to someone behind you, and you're like, oh, it's disappointing.
I also don't usually like to sneeze onto people.
You like to? Like you aim at them?
Yeah.
Okay. So you use chemical, like biological weapons is what you're doing, like.
Basically, yeah.
I got you. So let's see. When I multiply these two things, they are of the same base, the b's. So I add the exponents. 4 plus negative 3 is 1, and the denominator is still 12.
Now you have to move the person downstairs.
Yeah, so I'm dividing two radicals. I'm going to subtract their exponents, and I always move the little guy to the big guy. Little is the negative 6 because that is much less than positive 1. I'd rather have $1 than negative $6. So I think you'd agree. So b to the 1/12 minus a negative 6/12. What is going on with that? What does that even mean, guys? Plus, right? Okay. And who's living upstairs? 1. Okay, so 1 over 8. B to the 7/12. Okay. Am I done? We wish. We wish. Because b to the 7/12, I've got a denominator in my exponent. In my denominator. Wait. That's weird. I just had a denominator in an exponent that was within a denominator. That was like super weird. But basically that means there's a radical in the denominator. So if I was to write that as radical form, it'd be more apparent to us. That is the same as 12th root of b to the 7th. Right? So what do I do, friends? What do I do to get rid of this radical? Why the 5th? Where did you get that number?
7 plus 5 is 20.
Because, right, I want to multiply it by some exponent that when I add to 7, we'll be able to cancel with the 12. Good call. Good call. So that's the 12th root of b over 8. Oh, I see. Yeah, good catch. But bam. So the 12th root of b to the 5th, now I get the right answer, over the 12th root of b to the 12th, which is the 12th root of b to the 5th over 8. And what is the 12th root of b to the 12th? B. Technically, it'd have absolute values on it. But we're not really caring about that right now. So this is a radical version of my answer. Could someone give us the rational version of my answer? B to the what? What? To the 5/12. Because the index of my radical becomes the denominator of my exponent. There's like so many math words in that, but it's so accurate as well. All right, friends. Thanks for watching. Have a great day. Bye-bye.